Hello everyone on YouTube. Today I'm going to talk about physics. This is a simple problem that involves the Bernoulli's equation. So the problem says the following. A village maintains a large tank with an open top containing water for emergencies. The water can drain from the tank through a hose of diameter of 6.60 centimeters. The hose ends with a nozzle of diameter of 2.20 centimeters. Then a rubber stopper is inserted into the nozzle. The water level in the tank is kept 7.50 meters above the nozzle. So we have three different questions. First, we have to calculate the friction force exerted on the stopper by the nozzle. So the first step is to write the complete Bernoulli's equation. Furthermore, we have to apply each of the data we have and complete with this specific data all the Bernoulli's equation. Moreover, we have to cancel the parts that are thus necessary to make an appropriate calculation of the pressure. So, after all the calculations, we obtained the final value of 7.3 10 to the 4th pascals. We have to take into account this information to proceed with the next parts of the problem. Then, we need to make the free body diagram of this particular statement to analyze what happens with the friction. As we can see here, the force of water goes to the right, the force of air goes to the left, and as always the friction is opposite to the movement, so it goes to the left. We write the appropriate second Newton's law. This law states the following. The force of water minus the force of air minus the friction force equals 0. There is no movement, right? So it equals 0. So next step, we have to replace each of the forces of water and air with their definition, that it's pressure multiplied by area. So we isolate the friction force, and with we have all the data and we can calculate it directly. So finally, the numerical value that we obtain of the friction force is 27.9 newtons, right? And we have our first answer. Then we have to proceed to the second statement, to the question B. So the question, the following question says that the stopper is removed. So we need to calculate what mass of water flows from the nozzle in 2 hours. So as a first step, we have to rewrite the Bernoulli's equation, but this time we have to apply the different data that we obtained. We consider that P1 plus 7.35 10 to the 4 pascals plus 0 equals P1 plus 0 plus 1/2 of 1000 times B2 square. We isolate B2 square to calculate this velocity. We have to remember that in this time there is movement, so we can isolate B2. Once we have the B2 value, we proceed to calculate the mass in 2 hours. We use the formula of pressure volume equals pressure area velocity 2 times t. This is because there's a certain relationship with the classic equation that we find of x equals x0 plus bt. We use this reference to apply this to this certain formula, and now we can calculate the mass using this relationship. So 1000, that is our 1000 multiplied by p, and the radius, that is 0.011 to the square, times the velocity, that is 12.1 meters divided by second. And finally we have to multiply this quantity by 7200 seconds. And finally we obtain the value of 3.32 10 to the 4 kilograms. So finally, in the C part of the problem, we have to calculate the gauge pressure of the flowing water in the hose just behind the nozzle. So we use a relationship that says that A1B1 equals A2B2. We know that the area of a circle is P times radius to the square. So we use the appropriate data for each of the parts of the equation, and we can obtain that the velocity of big one is 1.35 meters divided by second. So finally as we have this velocity, we can use the Bernoulli's equation to find the pressure, the gauge pressure. Not that it's the difference of pressures of P1 and P2. So we rewrite as a final step the Bernoulli's equation, and we, as always, we have to look for the certain data we have and cancel the parts that we don't need. We cancel these two parts. Finally we apply our data and we isolate. We have to finally isolate P1 minus P2 to obtain the final result, that is the gauge pressure. So Okay, we almost finished to write the Bernoulli's equation. Okay, so we can already see that we have the appropriate data to isolate P1 minus P0, and we obtained the final result of 7.35 10 to the 4 pascals. This is our gauge pressure, and as we see, we have completed the different 3 questions that our problem required. As we can see, in all the problem we applied only the Bernoulli's equation, and we relationate all the equations, that simple equation like the density mass divided by volume, and the equation of force equals pressure times the area. So here's a happy paper, and see you at the next video.